All right, this is E1.7, which is the Cartesian coordinate system. This is a review of graphing basic points, finding the distance between points, and using that to incorporate some triangles, okay? So the first thing we want to go over is just a refresher of basic plotting points. Okay, whenever we plot points, there's 4 possible places on the graph that we could plot these points, and those are called quadrants. Okay, the quadrants of the graph are defined by Roman numerals, not regular numbers. They have to be Roman numerals. And we start with Roman numeral 1 up here in the top right-hand corner, and then we go counterclockwise. So this would be the second quadrant, this would be the third quadrant, and this one would be the fourth quadrant. Okay. I also wanted to go ahead and label the X and Y axis just for those of us who are a bit rusty. Okay, the horizontal axis is our X axis, and the vertical axis is our y-axis. So anytime we see an ordered pair, okay, an ordered pair is just a point on the graph, which we write as x, y. Okay, our x is referring to our horizontal axis, and our y is our rise or vertical fall. Okay, so on these next few, A through F, we want to go ahead and plot the points and then list what quadrant they're in. So the first one is 8, -2, so that means my x value is 8 and my y is -2. So since 8 is positive, I'm going to the right 8 places, and then my y is -2, so from there I'm going down 2. So this would be point A, and notice it falls in quadrant 4, so I'm going to go ahead and put a Roman numeral 4 here. Okay, we're going to do the same thing with B through F. If you want to work ahead of me and then check yourself, you can, or you can work along with me. Okay, B is 3, 4, so my x is +3, so I'm going to the right 3, and then my y is 4, so from there I'm going up 4. So this is B. It lands in quadrant 1. C is 0, 7, so my x, I'm not going left or right because my x value is 0. My y is 7, so I go up 7. So here's my C point, and notice it's not in quadrant 1 or 2. It lands right on the y-axis. Okay, so if it lands on an axis, we just label this as on the y-axis. Okay, the ordered pair -5, -1 for D. I go left 5. 1, 2, 3, 4, 5. Since my y is, or sorry, since my x is negative, and since my y is negative, I go down 1. Okay, so this is D, and notice it lands in quadrant 3. And then E, I go -3, 0. My x is -3, so I'm going left 3. And my y is 0, so I'm not going anywhere from there. So this one lands on the x-axis. Okay. And then my last one, -3, 3. Again, x is -3, so I'm going to the left 3. And then my y is +3, so from there I'm going up 3. So this is my point F, and it lands in the second quadrant. Okay, not too bad. All right, so what we want to do now is we want to look at using the Pythagorean Theorem to find the distance between the 2 points, 1, 2, and 4, 6. Okay, so before I do that, I'm actually going to scroll down a little bit and look at what is the Pythagorean Theorem. Okay, we've all heard of it. It's a squared plus b squared equals c squared. Okay, where a, b, and c are the sides of a triangle. Okay, and more specifically, the sides of a right triangle. We know a triangle is a right triangle if it has a 90-degree angle. Okay, the hypotenuse, which we label C in our Pythagorean theorem, is the length of the triangle that is opposite the 90-degree angle. Okay, length opposite the 90-degree angle. Okay, so that means this would be our C. Here's our 90-degree angle, and C is opposite that. Okay, our legs, the legs of the triangle, here I'm going to put here our hypotenuse is C. The legs are our A and our B, okay, when we're talking about the Pythagorean theorem, and these legs are the lengths or the edges adjacent. Okay, adjacent means touching the 90-degree angle. Okay, and it doesn't matter which order you do them in. I can call this one A and this one B, or I could call the other one A and the other one B. Okay, it doesn't really matter. As long as A and B are the two that are touching the 90-degree angle, we're good. Okay, so what this says is if I take the two lengths or the two edges, A and B, and I square those lengths and add them together, that's the same as if I were to take my hypotenuse, or my length that's opposite the 90-degree angle, square that. Okay, so we're going to use that to see, to see if we can figure out the distance between these 2 points. Okay, so I'm going to go ahead and just write the Pythagorean theorem we know is a squared plus b squared equals c squared. Okay. And now in order to do this, we need a triangle, right? And right now we just have a slanted line. And I can't count how many units there are between these 2 points. So what I'm going to do is I'm going to go ahead and just drop this down and write this over and create a little 90-degree triangle. Okay? So I'm going to label this as A, this is B, and this is C. Okay? So if I can figure out what the lengths of A and B are, then I can use the Pythagorean theorem to figure out C, or my distance between those 2 points. So I'm going to go ahead and use a different color. If I want to find this length right here, how long is side B, I can do it 2 ways. One, I can just count the boxes, right? I can see 1, 2, 3, 4. It's a distance of 4. Okay. The other way that I can do it is if I were to label these points. I know this point is 4, 6, and I know this point over here is 1, 2. So I could find the distance from this top point down to the bottom, that length B, by just subtracting. Okay, if I'm going up and down, that's my y, or my change in my y. So notice if I look at my high y value, it's 6. And my low y value is 2. So if I do 6 minus 2, that gives me that distance of 4. And I realize it's easier to count the boxes, but we're going to apply this in a minute, so that's why I'm going through it. So I'm going to go ahead and put over here that my b is 4, and I'm going to go ahead and square it because that's what the problem says to do. Now I want to do the same thing with this distance a. If I want to find the distance a is, I could just count the boxes, which give us 3. Or I can think I'm looking at the horizontal, so I'm looking at the change in x. So I look at my bigger x value, which here is a 4, and I subtract my smaller x value, which from my first point is a 1. So 4 minus 1, this gives me a distance of 3. So I could write it over here. It makes more sense. Okay, so I know that my a value is 3 squared. Okay, and then now that I know what those two sides are, now I should be able to figure out what c is. Okay, so 3 squared gives me 9. 4 squared gives me 16, and I know that if I add those together, it gives me c squared. So 9 and 16 is 25 equals c squared, and then to get c by itself, I take the square root of both sides. Now normally we always do plus or minus when we take the square root. Here it's not as important because notice c is a distance. It's the distance between those 2 points, and since distance never negative, then I really don't need that negative answer. Okay, so I'm just going to put over here, no negative distances. Okay, so that means that my distance is 5. Okay, so the distance between these 2 points are 5. So notice what I did is I figured out what's the length of that side, what's the length of this side, and then I squared that length and squared the bottom length and added them together to figure out what my hypotenuse was. Okay, so we're going to use that same idea, but now we're going to apply it to any points. Okay, any points on any graph, not necessarily known points, and see if we can come up with a formula to apply this to any 2 points. Okay, so notice here instead of using actual points, I'm saying x1, y1, x2, y2. So I'm going to do the same thing. I'm going to draw a triangle. Notice here my points are not very pretty. They land in between the boxes, right? So this one wouldn't be as easy. I couldn't just count, how many boxes are in between because it doesn't land right on the intersection of 2 lines. But I can solve it the same way I did before. I can still use a squared plus b squared equals c squared, okay, where c is my distance. Now instead of using a c, I'm going to go ahead and use a d. I'm going to call this d because I want to find a distance. Okay, so instead of using a C, I'm just going to call this D for distance. Okay, and we're going to see if we can come up with a generic distance formula that will work for any 2 points. So I'm going to work it the same way I did before. My points are already written in for me, so I'm going to figure out how I can find this distance of this side B. Okay, I'm going to go ahead and call this one my B side, call this one my A side. If I want to find the distance between B, remember, just like we did it last time, I'm looking at a vertical line. So to figure out the length of that vertical line, I look at the higher y value and the lower y value, and if I subtract them, that will tell me how long that line is. So my higher y value here is y2, and then I would subtract my lower y value, which is y1. So the distance of that B length is y2 minus y1. So I'm going to go ahead and just plug that in here, y2 minus y1, and I'm going to square it, right? Before we got a nice number, but here, since we don't know what the points are, we have to leave it with y1 and y2. I want to do the same thing with the A length side. Okay, it's horizontal, so to find the change there, I look at my bigger x value and I subtract my smaller x value. So in this case, my bigger x value is x2. I subtract my smaller x value, which is x1, and whatever the difference is, that tells me the distance or the length of that A line. Okay, so I'm going to go ahead and plug that in. So I have x2 minus x1 squared. And then just like before, once I know what those values are, if I add them together, that should equal my c squared, which in this case we're calling d for distance, my distance squared. Okay, then when we wanted to get distance by itself, we don't want to solve for d squared, we want to solve for d. So remember, we took the square root of both sides. So I have x2 minus x1 squared plus y2 minus y1 squared equals the square root of d squared. And again, I'm going to go ahead and put plus or minus just because we're used to doing that. But since we're solving for a distance, I'm still going to throw out that negative. Okay, so I'm going to go ahead and put no negative distances. Okay, so what I end up with is the square root of x squared minus x1 squared plus y2 minus y1 squared is equal to d. So that means the distance between these 2 points, which we have no idea what these 2 points are, but the distance between them I can find with this formula, no matter what the points are. Okay, so this is actually our distance formula. So I'm going to go ahead and down here, it says the distance between 2 points x1, y1 and x2, y2 can be found by using this formula that we just came up with. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now I'm not going to require that you derive this formula yourself. I'm not going to make you draw the picture and figure out how to come up with a formula. However, on an exam, I'm not going to give you this formula. You have to remember it. So if you're one of those crazy note-taking people, you might want to go ahead and just highlight this and know that this is something that you need to memorize. Okay? Memorize for exam. Okay? Because that won't be given to you and you will need to know it. So now that we know our distance formula, let's go ahead and use it on an example. So this one says, using the distance formula, find the distance between these 2 points. So I'm going to go ahead and label this one x1, y1, and the second one x2, y2. So the distance formula tells us we do the square root of our second x, which here is -2, minus our first x, which is 3, squared, plus our second y, which is 8, minus our first y, which is -5 squared. And I'm going to put parentheses around the -5 since it's a negative. Okay. And now we just simplify. Remember, anytime we have double negatives, it becomes positive. So this gives us -5 squared plus 8 plus 5 squared. And then I'm just going to keep simplifying. -5 squared is 25 plus 8 and 5 is 13 squared. So I get 25 plus 169, which when I add those together gives me the square root of 194, I believe. Yes, 194. Okay. Now, If we're talking about the distance something is, like how far is this building from this building, we wouldn't normally say, oh, well, it's a distance of the square root of 194 feet, right? We don't talk about distance like that. So we are going to go ahead and get a decimal answer. But in my math lab, it will ask you to enter the exact answer using radicals, and it'll ask you to enter a rounded decimal answer. So when it asks you for the exact answer, that's the square root of 194. Okay, so I'm going to go ahead and say, for our solutions, the square root of 194, when it's written like this whole piece, this is called our exact answer. Okay, and then we're going to go ahead and get a decimal. This is approximately 13.93. Okay, and I'm going to go ahead and say we usually round to 2 or 3 decimal places. Okay, and my math lab will tell you round to the nearest hundredth, round to the nearest tenth, round to the nearest thousandth, or however. Okay, so when it asks you enter your exact answer, most of the time it will give you a box like this, and it'll already have the square root in it, and you'll just put in 194. Or it may look like square root of, and then it may put the box in here and you enter 194. Okay, so your exact answer is when it's under the radical, and then your actual answer that they want you to enter in the end is the decimal that's rounded to 2 or 3 places. Okay, so let's go ahead and move on and look at something else. Here I want to go ahead and think about what the midpoint is. The midpoint of a line is the point that lies equidistant from each endpoint. In other words, it means it's the exact middle of that line. So here I have a line graphed for me. It says find the midpoint of the line segment between the 2 points -3,1 and 5,1. Label this point on the graph to the right. Now, anytime we find the exact middle, what we're really doing is we're just averaging, right? If I have a grade of 80 and I had a grade of 100 and I want to know what's the exact grade that's in the middle of those two grades, I would do 80 plus 100 divided by 2. It's just like an average. Okay, just show that. I'm going to go ahead and show you another way to do it. If you wanted to find the distance, I could count up these boxes, right? This is the point -3,1, and this is the point 5,1. So I could count from one point to the other. I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this line right here is a distance of 8 units, which means if I go to the exact middle, I could take half of that, right? Halfway would be 4 units. So I'm just going to say 4 units is halfway. So I could just count over 4 boxes, right? 1, 2, 3, 4. And this point right here would be my midpoint. And then I just label it. That point is actually the point 1, 1. Okay, so what I want to point out is we can find it by finding the distance and then just starting from your first point and counting over that distance and figure out what that point is. Or, like I said before, we can average the two values. Now notice this is a straight line that's going straight through the same y value. This whole line is going through the y value 1. So that's not going to change if it's on the same line. What is going to change is my x values. So if I wanted to find the midpoint by averaging, I would do -3 plus 5, which are my two x values, and then divide by 2. So notice -3 plus 5 is 2, divided by 2 is 1. Okay, so this is my middle x value. Okay, and then my y value is the same. So since my y value is the same, then my midpoint here would be 1, 1. Okay, so there's a couple different ways to do it. So let's look at another way. This next one says find the midpoint of the line segment between the 2 points -4, -2, and 6, -2. So I'm going to go ahead and plot these points on here first. If I go to -4, it means I'm going on my x-axis left 4, and then my y value is -2, so I'm going down 2. Okay, so here's -4, -2, and then my next point is 6, -2. So this was 5, 6, and then down 2. Okay. 6, -2. And since it says Find the midpoint of the line segment. I'm going to go ahead and draw a line between the two. Okay. Whoops. Let's pretend that's straight. Let me try again. Well, straight enough anyways. Okay, so I can do this the same way I did before. I can count up the distance here, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 units between the 2 points, which means that halfway would be 5 units. Okay, so 5 units is halfway. So I could just go over 5 units from one of the points. So if I start at -4, 2 and I go 5 units to the right, 1, 2, 3, 4, 5, I end up with this point right here, which is the x value is 1, the y value is -2. So this would be 1, -2, which is my midpoint. Or I can think about it again of just averaging my x values. Okay, my y's all go through -2 because they're all on that line. So if I were to average my x values, I could do -4, which is my first x value, plus my second x value, which is 6, and then take the average by dividing it by 2. So -4 plus 6 is 2. When I divide that by 2, I get 1. Okay, so this is my middle x value. Okay, and again, my y value stays the same because it's on the same line. So my y value stays the same, which is -2. So I get the point 1, -2. Okay. I want to look at another one. The only difference here is we're looking at a vertical line now instead of a horizontal line. So when we look at a vertical line, now we're going to have our x value is going to be the value that's not changing. And to find our halfway point, we're going to be using our y values instead of our x's to average. Okay, so let's go ahead and look at this one. So in this one it says find the midpoint of the line segment between the 2 points 1, 5 and 1, -3. So this is my 1, 5 and this is my 1, -3. So again, I could do it by counting. If I find this total distance, I have 1, 2, 3, 4, 5, 6, 7, 8. So if this is 8 units, then that means 4 units is halfway. Okay, so if 4 units is halfway, I can just start at one of these points and go 4 units in the other direction. So if I start at the bottom one, I would go up 4 units. 1, 2, 3, 4. Okay, so here I would know that my middle point is 1, 1. Okay, now the way I want to think about it is averaging. Okay, my x value is going to stay the same because this line all goes through the x value of 1. So to find my y value, I would just average the two. So I'm going to go ahead and do my top y value, which is 5, plus my low y value, which is -3, or you can do it in the other direction. You can do -3 plus 5, doesn't matter either way, and then divide it by 2 to average it. 5 plus -3 is 2, divided by 2 gives me 1. Okay, so this is my middle y value. Okay, and here my x value stays the same because it's just a line straight through the x value of 1. Okay, so that means that my midpoint for this line segment would be 1, 1. Okay, does that kind of make sense? We're going to tie it all together here in a minute. Same thing on number 3. Number 3, it says we're going to find the midpoint of the line segment between the 2 points -2, 6. So I'm going to go back 2, up 6. So this is -2, 6. And -2, -4. So again, back 2, down 4. So this is -2, -4. So I'm going to go ahead and try again to draw a straight line. It's kind of straight. Let's pretend it's on that line. Okay, and I'm finding the midpoint. So again, I could do it by counting. I could figure out what's my overall distance, my units here, which if I count them up, I have 10. Okay, so these 2 points are 10 units apart, which means that 5 units is halfway. So I could start at my higher point and go down 5, or I could start at my lower point and go up 5. If I start at my lower point and go up 5, 1, 2, 3, 4, 5. Here's my midpoint, which this point is the point -2, 1. Okay, so notice all my x values are -2 because they all land on that line. So again, we can do it that way, or if it's something not pretty that doesn't have a perfect halfway point, we can do it by just averaging. So I'm going to average my y values again. So I'm going to take my higher y value, which is 6, plus my lower y value, which is -4, and divide it by 2. 6 plus -4 gives me 2, divided by 2 gives me a 1. So that means this is my middle y value, and then my x value stays the same. Okay, because it's still on that line that goes through, all my x's are -2. So that means my midpoint here is -2, 1. Okay, so let's go ahead and apply this to a general example. Okay, if I look at a general example, it says, can you find the midpoint of the line segment between the 2 points 6, -3, and -4, 5? So I'm going to go ahead and label them. This one is -4, 5, and this one is 6, -3. Okay, now it's a little bit harder here because this is not just a straight line up and down or horizontal, right? So I'm going to have to look at this sort of in terms of my triangle again. If I want to try figure out what is my middle value here, since I don't have a straight line where one variable is staying the same, I have to think what is my middle x value and what is my middle y value. So if I look at my y value, I need to know from here all the way down to my new y value, okay, from my y value at the top at 5 down to my y value of -3, what would half of that be? What would half of that distance be? Okay, so I'm going to look at this distance, and I need half. Okay, so I'm going to count this up. I get 1, 2, 3, 4, 5, 6, 7, 8. So that's a distance of 8, which means that halfway would be 4 units. So if I come down 4 units from my top point, 1, 2, 3, 4, this would be my halfway y value. I'm going to go ahead and put a point here. Notice that looks pretty halfway. Okay, so halfway, and then I need to figure out what would be halfway on my x's. So if I look at my x's again, I'm just going to draw this line on over, and I'm going to say from here to here, I need half this distance. Okay, so again, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, half of that distance would be 5. So if I start at this point and go back to the left, 5, 1, 2, 3, 4, 5. Notice if I take half that and draw it up to my line, this is going to be my midpoint. Okay. Now, we could do this one of two ways, just like we did before. We can count those distances like I just did. I found 8 and I just took half, which was 4, and counted it down. On the x's, I found the whole distance, which was 10, so half of that would be 5, and counted it over. But sometimes it doesn't come out nice and pretty like that. So what we want to do is we want to take the average of our x's and the average of our y's, because really when we're taking half, notice when we take half and trace it over and half of our x and trace it up, that gives us the exact middle point of this line. Okay, so I'm going to go ahead and just write, we're finding, find the average of the x values and the average of the y values. And then we just write those two values as an ordered pair. Okay, here it's easy to see that our midpoint is going to be 1, 1. So I'm going to go ahead and just try to write a formula for that. It says use the formula given by the instructor to find the midpoint. So let me go ahead and give you the formula. Notice below it says for any two given points, x1, y1, x2, y2, our midpoint, which I'm just going to abbreviate, is the same as if I average my x's, so I'm going to do x1 plus x2 and then divide it by 2. That gives me my middle x. And then to find my middle y, I do the same thing. I average my y's. So I'm going to do y1 plus y2 divided by 2. So let's use that on this example up here and see if we can find out that our midpoint is 1, 1. So our midpoint, if we average our x's, okay, I'm going to call the higher point my first point and the lower point my second point. So I'm going to go ahead and label this one. I'm going to call this one x1, y1, and I'm going to call this one x2, y2. Okay. So that means that my midpoint is equal to my first x, which is -4, plus my second x, which is 6, divided by 2, and my first y, which is 5, plus my second y, which is -3, divided by 2. And then I just simplify. -4 and 6 is 2 over 2. 5 plus -3 is +2 over 2. And then if I reduce, notice this gives me 1, 1. Okay, so from here on out, again, we're going to use our midpoint formula so we don't have to draw triangles and take half the distances and stuff. So now anytime we want to find the midpoint between any two points, we just use this formula. Average the x's, average the y's, write it as an ordered pair. Again, this is another thing we want to memorize for the exam. Okay, it won't be given to you, so you're required to have that knowledge. Okay? Okay, so now that we have a formula, let's look at another example of just using that formula. Excuse me. So this says using the distance formula and the midpoint formula. So we're doing both, distance formula and midpoint formula. We want to go ahead and find the distance and the midpoint for the following ordered pairs. So I'm going to go ahead and write them. We know our distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And our midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, so I'm going to go ahead and just rename these points. I'm going to rename this point x1, y1 and x2, y2. Okay, so we can follow along. So that means our distance is equal to the square root of our second x value, which here is 5, minus my first x value, which is -3, squared, plus my second y value, which is -9, minus my first y value, which is -3. Okay, and then I'm just going to simplify. So here my double negatives become positive, so this is 5 plus 3 quantity squared, and -9 plus 3 quantity squared, which gives us 8 squared plus -6 squared. So when I work that out, 8 squared is 64, -6 squared is 36, and notice if I add those together, I get the square root of 100. Now, if they ask you for the exact answer on this one, do not put square root of 100, right? Because the square root of 100, we know, is 10. So here our distance would be 10. Okay, let's look at our midpoint. To find our midpoint, we do our first x value, which is -3, plus our second x value, which is 5, divided by 2 to find the middle point. And then same thing with our y's. First y is -3, plus our second y, which is -9, and then divide it by 2. Now all I do is simplify. So -3 and 5 is +2 divided by 2. -3 plus -9 gives me -12 divided by 2. So when I simplify, I get the point 1, -6 as my midpoint. Okay. Clear as mud? Okay. Let's go ahead and look. There's one on the next page. It shows that I have an example, and then after that, there's a practice one. But if you look really close, the example at the top of page 5 and the practice problem are the exact same problem. So I'm not going to work it. I'm going to give you a second to go ahead and work this practice problem, and then I'll come back and do it in just a second, okay? All right, so on this practice one, we're finding the distance and the midpoint. The distance, we have our formula, so we do our second x minus our first, square that, add it to our second y minus our first, and square that. Notice with double negatives, it becomes positive. So I end up with the square root of 64 plus the square root of, the square root of 64 plus 64, which is the square root of 128. That is our exact answer. Since it doesn't simplify to equaling a perfect square, we don't have to reduce the radical or anything. We just leave it as the square root of 128 for our exact answer. Then for our rounded decimal answer, we can go ahead and plug it into our calculator and round to our 2 or 3 decimal places as my math lab asks us, okay? So here I did 2 decimal places, which should be roughly 11.31, okay? Then for our midpoint, again, we average our x's, average our y's, write it as an ordered pair. When we average our x's, we should get 1. When we average our y's, we should get 2. Make sure you write it as an ordered pair. If you just say x equals 1, y equals 2, it's incorrect. This represents a point on the graph, so it has to be written as an ordered pair, okay? All right, so let's go ahead and go on and see how we can use this, okay? So we're gonna go ahead and say a fun activity, okay? Our fun activity here is going to be applying what we know about the distance formula and the edges of a triangle, okay, in order to find perimeter. So remember, whenever we find perimeter, the way that we find perimeter is we find the distance of each length of a triangle and we just add all the sides up, right? So I'm just going to say perimeter is equal to the sum of all edges, okay? So for vertices of a triangle, or if they give us just the points of all the corners, what we have to do is find the length of each edge and then add those lengths, or let's say find the length of each edge using the distance formula. Using the distance formula, and then add those lengths together. To find the perimeter, okay? And I'm going to go ahead and say, you know, sometimes when we find the distance formula, we need the exact length. Other times we want the decimal form. Here, since we're finding the perimeter, we're looking for a measurement all the way around. Since we're finding a measurement all the way around, I don't want to leave it in radicals. So I'm going to go ahead and say that we can round this one. So down here, I'm going to go ahead and just say round to 2 decimal places. Round to 2 decimal places. Okay, so, excuse me, we're given the 3 points of a triangle. So I could graph them and draw a triangle and label the sides, but instead of doing that, I'm just going to label these points A, B, and C. Okay, so I'm going to call this one A, this one B, and this one C. Okay, and then I'm going to find the distance from one point to the other. So I should have 3 sides, which means I need to do the distance from A to B, I need to do the distance from B to C, and then I need to do the distance from C to A. So that way you get all 3 sides. And then once I know the 3 distances, I just add them together to get perimeter. Okay, so to go from A to B, I'm just going to call this AB. Okay, the side AB, the distance from point A to point B, I'm going to use my distance formula again, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So here for A and B, I need to label these points. I'm going to call this one, actually I'm not going to label them because then I have to relabel them each time. So when I say my second x, we'll call that from whatever the second point is. So here, since I'm going from A to B, B will be my second point, A will be my first point. So I need to do the x value of my B point, which the x value of my B point is -2, minus the x value of my A point, which is -2 squared, plus the y value of my B point, which is 1, minus the y value of my A point, which is 3. And now I just simplify. So I have the square root of -2 plus 2 squared plus -2 squared. Now -2 plus 2 is 0, so 0 squared is still just 0, plus -2 squared, which is 4. So what I'm ending up with is the square root of 4, which is just 2. Okay, so my side AB has a length of 2. Now I need to find the length between the point B and the point C. So I'm going to label this BC. And again, my distance formula, I'm going to go ahead and write it out. So I'm going to call this x2 minus x1 squared plus y2 minus y1 squared. So again, now my second point is C. So I need to do the square root of my second x, which is the x from my C point, which is negative 5, minus the x from my first point, which is my B point, which is negative 2 squared, plus my second y, which is from my C point, which is negative 2, minus my first y, which is from my B point, which is 1 squared. And then I just simplify. I'm pretty sure the hardest part of these problems is just keeping our x's and y's straight, from which one's from which point. So here I'm going to get the square root of negative 3 squared plus negative 3 squared. So I end up with the square root of 9 plus 9, which is the square root of 18. Now the 18 is not a perfect square, so I'm going to go ahead and approximate this. This is approximately equal to, if I get a decimal form, 4.24. Okay. And then I need to find my last length of my last leg of my triangle. So I need to go from C to A. I went from A to B, B to C. Now I need to go back to C to A. So again, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So I need the second x value. Notice my second point, the way I wrote it, CA, is my A. So my x value of A is negative 2 minus my x value from my first point, which is C, is negative 5 squared, plus my y from my second point, so my y from my A, which is 3, minus the y from my first point, which is my C point, which is negative 2 squared. Okay. So I get the square root of negative 2 plus 5 quantity squared plus 3 plus 2 quantity squared, which is going to give me 3 squared plus 5 squared, which is the same as 9 plus 25, which is the square root of 34, which again is not a perfect square, so I'm going to go ahead and approximate this length as being 5.83. Okay. All right, so now I know the lengths of all the sides of my triangle. So now that I know the lengths of all the sides, I just add them together. Okay. Perimeter is equal to the AB length plus the BC length plus the CA length. So I'm doing 2 plus 4.24 plus 5.83. Excuse me. When I add all these together, I'm just going to do it 2 at a time. 2 plus 4.24 gives me 6.24 plus 5.83 leaves me with 12.07. Okay, they didn't tell us it was centimeters or inches or anything like that, so we're just going to leave it as 12.07. Make sense? Use the distance formula to go from one point to the other, which tells you the length of that edge of the triangle, and you do that for each of the edges, all 3 edges. And once you know the distance of each edge, to find the perimeter, we just add them together. Okay? We're going to look at another way to use triangles and the distance formula, or the distance formula rather, to determine what type of triangle we're dealing with. Okay? So on the next page, we have 3 types of triangles that we deal with in this class. The first type is a right triangle. And a right triangle we notice basically because of the 90-degree angle. Okay? It has a 90-degree angle, and any triangle, specifically a right triangle that has the 90-degree angle, satisfies the Pythagorean Theorem, which we went over just a little bit ago. A squared plus B squared equals C squared, where remember A and B are the legs that are connected to the 90-degree angle, and C is our longest leg, or our hypotenuse, that's opposite the 90-degree angle. So in order to see if something is a right triangle, we just need to know what are the lengths of all the edges. And then we plug them into a squared plus b squared equals c squared. And if it makes a true statement, then we know it's a right triangle. Okay, I'm going to put on here because everybody always forgets. Remember, C has to be your hypotenuse. And the hypotenuse is always the longest length. C must be the longest edge of your triangle. Okay, otherwise it doesn't work. So if you come up with a triangle that has sides 1, 3, and 10, if you don't use C for 10, it's not going to work out, even if it is a right triangle. Okay. All right, so that's a right triangle. The second type of triangle we're looking for is an isosceles triangle. An isosceles triangle looks something, ooh, that's not straight, something like this, okay, where two of the sides have the same length. Okay, so that's what I'm going to put. Has two sides of equal, whoops, I don't know how to spell length apparently, of equal length. Okay, now I don't care about three sides. I don't care if it's an equilateral triangle. I'm only looking for isosceles, which means that two of the sides are the same length. Okay, so right triangle, we're looking, does it satisfy Pythagorean theorem? If it does, it's right. Isosceles, if there's two sides that are the same, then it's isosceles. If it's any other triangle, it's a scaling triangle. So there's not a special thing that we have that we check for. It's just if it's not isosceles and not right, then it's scaling. Scaling doesn't have a 90-degree angle. It doesn't have any equal sides. It's just kind of that other category of here's where all our other triangles fall. So I'm just going to say this is every other triangle. Okay. Doesn't satisfy Pythagorean theorem, and no equal sides. Okay, so not the most special triangle ever. So when we're checking for these, we find all the lengths. If there's two equal lengths, then it's isosceles. If there's not two equal lengths, we check to see if it satisfies Pythagorean theorem, which if it does, it's right. If it doesn't, then it's scaling. Okay, so that's what we're going to do for these next ones. Determine whether the triangle with the given vertices or edge points is a right, isosceles, or scaling triangle. So again, I'm going to call this triangle A, or sorry, I'm going to call this point A, point B, and point C. So I need to find the distance between A and B, then the distance between B and C, and then the distance between C and A, and then look at those lengths. So again, I'm going to go ahead and write the distance is the square root. Actually, I'm going to write up here so I don't have to keep writing it. x2 minus x1 squared plus y2 minus y1 squared. So here, I'm doing my second x, which comes from my b, which is -2, minus my first x, which comes from a, which is 1, plus my second y, which comes from b, which is 0, minus my first y, which comes from a, which is 2. And then I simplify. So -3 squared plus -2 squared. Underneath my radical, I get 9 plus 4, which is the square root of 13. Now here, we're not actually finding perimeter. So if we're not finding perimeter, I don't even need to get a decimal approximation, because all I'm looking for is, are these lengths equal, or do they satisfy Pythagorean theorem? So for this one, I'm just going to leave it as an exact answer. Okay, then I'm going to go ahead and find the distance from B to C. So I do my second x value, which is from C, which is 3, minus my x value from B, which is -2 squared, plus my y value from C, which is 5, minus my y value from B, which is 0. I don't know why I put parentheses. I don't need parentheses. Minus 0 squared. So I end up with the square root of 3 plus 2 quantity squared plus 5. Whoops, not 5 to the 0. 5 squared. Okay, so that gives me the square root of 5 squared plus 5 squared, which is the square root of 25 plus 25, which is the square root of 50. Again, square root of 50 is not a perfect square, so I'm just going to leave it like that, and then find my last distance, which is from C to A. So x value from A, which is 1, minus my x value from C, which is 3 squared, plus my y value from A, which is 2, minus my y value from C, which is 5. So I have negative 2 squared plus negative 3 squared, which means underneath my radical I have 4 plus 9, which is the square root of 13. So I'm going to go ahead and show you on this example. I don't know if I have another one. Yeah, I have one more. Okay, so first thing I look for, which is the easiest thing to check out, is do I have any equal sides? Which here I do. Okay, so notice I have the square root of 13 and I have the square root of 13. These are the same length, which means that this is an isosceles triangle. Okay, an isosceles triangle is never a right triangle, and a right triangle is never isosceles. So if you see the same lengths and you say it's isosceles, you don't have to check to see if it's one of the other triangles. It can only be one of the three. Okay, so let's look at another one, and then I'll have y'all do one, and then this section will finally be over. Okay, all right, so again, I'm going to label these A, B, and C. So I'm going to do the distance from A to B, then the distance from B to C, and then the distance from C to A. I'm going to write my distance formula up here. x2 minus x1 squared plus y2 minus y1 squared. So my distance from A to B is going to be my x value from B, which is negative 3, minus my x value from A, which is 5 squared, plus my y value from B, which is 7, minus my y value from A, which is 1. So I have the square root of negative 8 squared plus 6 squared, which gives me the square root of 64 plus 36, which again is the square root of 100. Okay. Now again, I don't mind. If you want to go ahead and say that that's 10, that's fine, but I'm just going to leave it in square root form at this point because I only care about are the lengths the same or are they not at this point. So distance from B to C, I'm doing my second x value, so my x value from C, which is 8, minus my x value from B, which is negative 3, plus my y value from C, which is 5, minus my y value from B, which is 7. Okay. So I end up with the square root of 8 plus 3 squared plus negative 2 squared. So I'm getting 11 squared plus 4, which means I have 121 plus 4, which is the square root of 125. Okay, not a perfect square, so I'm not going to simplify. I'm just going to leave it like that. And then my last distance is from C to A. So my distance from C to A, I do my x value from A, which is 5, minus my x value from C, which is 8 squared, plus my y value from A, which is 1, minus my y value from C, which is 5. So I have the square root of negative 3 squared plus negative 4 squared, which gives me a 9 plus 16 under my radical, which is the square root of, excuse me, of 25. Okay, again, that equals just 5. So notice if I look at all my sides, I have no equal sides. If I have no equal sides, then that means it's not isosceles. So I'm going to go ahead and just say no equal sides, which means that this is not isosceles. Okay, so the next thing I look for is to see, does it satisfy the Pythagorean theorem? So I'm just going to say Pythagorean theorem, maybe? So I'm going to say a squared plus b squared, does that equal c squared? So I need to look at my lengths. Now remember, I told you the lengths of the Pythagorean theorem, c has to be your longest length. So I'm going to look at them all in radical form. So I'm going to ignore this 10 and ignore this 5. The biggest, square root of 100, square root of 125, or square root of 25, my biggest would be the square root of 125. So this is going to be my C, and then the other two will be A and B, and it doesn't really matter which one you label A and B. So we'll let A be this one, and we'll let B be this one when we plug it in. Okay, so let's go ahead and say A squared. So that would be the square root of 100 squared plus B squared, so the square root of 25 squared. Does that equal my C squared, which is the square root of 125 squared? And the good thing about leaving it in radical form is anytime you square a square root, those just cancel. So I end up with 100 plus 25. Does that equal 125? Well, yes, it does, right? 125 is equal to 125. So since the Pythagorean theorem holds true, that means that this is a right triangle. Right triangle. Okay, makes sense? Find all the lengths. If there's two that are the same, it's isosceles. If there's not two that are the same, you check the Pythagorean theorem. If it works, it's right. If neither of those work, then it's scaling. Okay, so there's one at the bottom of the page for y'all to try. I'll give you a few minutes and then I'll go over it. Okay, all right. So on this practice problem, again, finding the lengths of all the triangle sides. So we go from A to B, B to C, C to B, back to A, and we use the distance formula. So notice once you do the length from A to B and the length from B to C, right away you can see that they have the same length. If you see that they have the same length, you actually don't have to keep going. You can stop right there and say it's an isosceles triangle. If you went ahead and calculated the distance from C to A, I went ahead and worked it out so that you could see if you did it correctly. Okay? All right, that's the end of 1.7, so you should now be able to do your E1.7 homework on My Math Lab. Let me know if you have any questions. Okay? Bye-bye.